Welcome to SeaRUG for 2021. My name is David Diars. I'm current president of the board of SeaRUG, and it's my pleasure to welcome you and to welcome our sponsor. I'll give a couple of introductory slides here and get off the virtual podium as quickly as possible. Pass it along to the information that you really care about to see today. So bear with me for a couple of minutes, and we'll get the meeting rolling. I'd love to really thank and introduce a new sponsor for SeaRUG. Although BIMBOX has been participated last year with a promotion and some content, but it's the first time that BIMBOX is actually sponsoring a meeting and presenting, and we've got ATG and BIMBOX together. Today we're going to have Buck Davis of BIMBOX and Brandon Melin of ATG USA. They're going to do a great presentation for us on emerging technologies and how they relate to our tech-intensive AEC workflows. And you can probably see I'm wearing my Commodore 64 T-shirt because we all know that that's when computers peaked. So you got a lot to live up to here in this presentation, Buck.
Nice.
No, seriously, I can't say enough good things about BIMBOX. For those of you that have been with us for the last handful of meetings, you know that I'm running a striker under my desk, and that someday Buck's going to come calling, wanting it back, and I'm going to disconnect my phone. So it's a fantastic piece of hardware, and I'm excited to have Buck and Brandon talk about not just hardware today, but how it relates to technology and dive deep into an ROI explanation and really help you make the point for why you need the right hardware, which is the right tool for the job. But enough about that. I want to thank all of our sponsors for 2021 that have signed up so far. We've got the calendar mostly filled up already, so this is great. A lot of familiar faces and a couple of new ones too, so always exciting. Really quick, want to, while I'm on this slide, kind of talk about the online situation versus in person. We would all love to be in person. SeaRUG is such a community that it's, I miss everybody. I miss, providing lunch for everybody. I miss the networking. It's really been a tough year since we've had to be online. But like I said earlier, it's the times we live in. Currently, the library is still sort of holding to the plan that at least until July, they're probably not going to be able to have meetings in person. And that's probably, that probably falls right in line with what the sort of state guidance is. We certainly hope that by July we can get together in person again, but we don't know. Situation's fluid, but we'll do our best. So, thank you so much for joining us online, and we'll make it work for now. And of course, a big thank you, as I always do every month, but a little bit more especially, beginning of the year and end of the year, always to all of our board members that help me put these meetings together and help curate the content and help kind of organize everything that is SeaRUG, right? So thank you, everybody. Really appreciate your work. And I'm sure, all the membership appreciates the time that you put in and volunteer to get this done. All right. And lastly here, check out our YouTube channel. Just search for SeaRUG on YouTube or go to this URL. And as you all know, we post our meetings up here. We'll be getting this recording, posting it up so you can share with your colleagues or share with somebody, that you think might be interested. And that's enough from me. That's about as long-winded as I ever want to be on these things. But being the first one of the year, I guess that I needed a couple of extra words. But I really a big thank you to ATG and BIMBOX, and I would like to just pass this along to Brandon and to Buck, and I'll shut up and I will talk to you at the end. Thank you.
Thanks, David.
All right. I really want to thank David and everyone there for having this. I hate that we can't be there in person. I love Seattle. I told some friends last night that I was going to be presenting to Seattle, and they're like, "You're here," and I was like, "No, unfortunately, I'm stuck in my house in San Diego." So it's nice to be here virtually. Today we're going to be talking about, hold on a second, productivity and performance in your AEC workflow. Productivity is going to be the key, and performance is going to drive that productivity. I'm Buck Davis. I'm the director of product at BIMBOX. And I am joined by Brandon Melin. He is the Director of Technology and Innovation at ATG. ATG is exclusive reseller of BIMBOX. So if you need to buy one, you have to talk to ATG. But Brandon is a great guy. He understands tech and understands hardware, as well as the workflow. So great person to talk to. BIMBOX, a little background about us. If you don't know about BIMBOX, this will be pretty educational. If you do know about BIMBOX, this will still be pretty educational as we kind of walk you through some things. But we were founded in 2015. I was working at Balfour Beatty from 2013 to 2016. But 2014, I was tasked, I was working as a project solutions manager for speccing out systems and software for a big Disney project we had. We had a BIM team, a VR system, and 3 laser scanning techs that were being deployed on a pretty big Disney project. And we bought them all Dells, really high-end Dell workstations, quote unquote, BIM workstations. And about 3 months into the project, everyone was complaining. And I was scratching my head. We'd spent close to $300,000 or $400,000 on hardware, and everyone was complaining. So I dug into the hardware and found that the specs that would be good for the systems that those people wanted were different, and they weren't really what Dell was sending us. So I had a background in hardware, and I had built systems before. So we started building hardware. The first systems we built were for CAD, Revit, and VR. The second systems we built were for scan registration. I didn't set out to start building hardware. I just couldn't find any companies in the industry, serving the industry, building the systems that I wanted spec'd. So started building systems for the Balfour team. Then we got some calls from mechanical contractors that I knew, some buddies working there, some civil contractors. And what started as a nights and weekends turned into a full-time night and weekend thing. And flash forward to today, we have our systems built by our integration partner, Ingram Micro. They're a $48 billion hardware systems integrator, one of the largest in North America. And we build, and produce over 1,000 systems a year. And we ship to 50 states in North America. And we're planning on going to Canada in the next 12 months. So we understand that time is your most valuable resource. When I was managing project teams, we never had enough time. That there's just never enough hours in a day, and you always have more work. So our goal was to provide the best workstations for the AEC industry. That's it. That's all we set out to do. And the way we do that, it's pretty simple. We reduce your downtime. That's the time you spend waiting for files to open or data process. We increase the primary time. That's the speed at which things happen when you're actually using applications. And we set out to improve the quality of your deliverable. That's done by giving you more time to focus on things like coordination, like modeling. So by reducing that downtime, we give you actually more effective time to focus on the things that are important, right? And if we do those three things well, we'll enhance the user experience, which inevitably is the goal of any manufacturer, right? So the one thing I want to challenge you with right now, and I want this to kind of be the heart of this presentation. If you don't do anything more than this is fine. But I want you to ask yourself why the computer you have right now is the right computer for what you do, right? Is it because the IT manager gave it to you? Is it because the company that sold it to you said it was quote unquote the BIM workstation? But if you don't have a good answer for that question, right? If you can't have a definite answer for that, I recommend that you reach out to Brandon or myself after this. We'll set you up with a time to talk to one of our technicians who's from the industry, who can kind of spec you out with a system that's right for your workflow. And I think you'll be surprised. We have some really good opportunities for a 30-day program for you to no commitment test the system, put it through its paces, spec it out how you want. If you don't like it, you can send it back, no commitment whatsoever. But we have 2 different systems. So we have a Striker 2 workstation, which is going to be a lower core count, higher clock speed. This runs at a 5.2 to 5.3 gigahertz all core clock speed. That means all the cores in the system are going 5.2 or 5.3 gigahertz all the time, all day long. It's perfect for multitasking with AutoCAD, Revit, Civil 3D, and ideal for Lumion, Inkscape, and Cyclone. So this is perfect for multitasking workflows. Although these are single core programs, a lot of times, and I know this from my personal experience, you might have AutoCAD open and Revit open, or Revit open and Revista or something. You don't just have one program open. Typically, you have 4 or 5 things going on at the same time and 2 monitors going on. So while they're single core, you're typically doing more than one thing. The next platform we have is our Osprey. So this is based off the Threadripper 3. You have a 24, 32, and a 64 core option, up to 256 gigabytes of RAM. A lot of times, this is going to be specifically for reality capture, photogrammetry, or post-process rendering. We do find, though, that we have VDC managers that like this because, and I know this personally from experience being a VDC manager, you use single core solutions, but you also jump in and do a little laser scan processing. VDC managers like the 24 core version of this because you have 48 threads to crush reality capture, and you also have a 4.5 gigahertz boost speed for when you're using single core solutions. Out of these 2 different desktops, we can configure and get the right setting for anyone in the AEC workflow, right? In the workspace. So these are the 2 systems we have, and they're fantastic for AEC technicians. This is really important. And as we go through some of the different components for an AEC system, this is kind of the philosophy we have. It's the aggregation of marginal gains. And it's pretty much, if you break every part of a processor system down and improve it by 1%, you get a significant increase when you put them all back together. I adhere to this in life, and I did this when I was in project solutions. But it's really powerful, right? So this visualized over the course of the year. Every day you're doing better. Every day there's a huge difference at the end of the year. And this is our goal, and this is what we're trying to do. Over the course of the year, giving you a benefit every day, the production delta is absolutely huge. And we're going to show you that with some different client ROIs and some different case studies we have. So we're not just harping on numbers. We're actually going to show you the impact of our systems in some clients' hands. But as we go through this, I want you to know every decision we make is based off this philosophy. Before we get into this, I kind of want people to understand the system, and I always like to do it visually with people. I'm originally from Atlanta, Georgia, and if you're familiar with Atlanta, it has kind of arteries that go into a city. You have 75 and 85 going north and south, and 20 going east and west. So you have your GPUs on the north side. On the south side, you have your Wi-Fi, your SATA drives, your LAN, your USBs, and your Bluetooth. On the west side, you have your M2s, and on the right side, you have your RAM. So the real reason I want to show this to you is because of speed and bandwidth, and I want to explain those 2 things because we're going to talk about them continually throughout this presentation. So when you think about speed and bandwidth, I want you to think about a highway, right? So if you have a 2-lane highway with a 75-mile-an-hour speed limit, the bandwidth is 2 lanes, the speed is 75. Now that's great, but like in Atlanta, if Monday morning you try to send 1 million cars down it, all of a sudden that speed's no longer 75, you have a traffic jam, right? But if you take that same speed and put it on an 8-lane highway, all of a sudden you have a lot more throughput to the city. So depending upon how you configure a system and how many lanes you give a component can directly impact that component's ability to talk to that CPU. So things like an NVMe drive, like that M.2, has a direct connection to the CPU, whereas if you were using a SATA drive, as we'll show you, you're sharing bandwidth with a lot of other things. So when we talk about drives and performance in a second, I want you to understand this. Also, I wanted to show you this. I was doing some testing on our 11th gen processor. It'll be released in a couple months. But this is important. So I was doing a burn-in test because we're doing some overclocking and stability. A burn-in test stresses all the components by just doing as many operations on each one as possible for 15 minutes. No surprise, your disk drive, the C drive, is the slowest component in a system. Next up would typically be RAM in most systems, and then a CPU, and then a GPU. The one thing I want to point out here is that our RAM actually has more operations completed than our CPU, and that's important. RAM is not a roadblock in our systems, and that's due to the fact we go with a really high speed, high performance RAM. A lot of different case studies and a lot of different things out there show that, well, high speed RAM doesn't make a big impact, but in an AEC workflow, Revit uses a lot of RAM. CAD uses a lot of RAM. All these different programs are very RAM hungry, and when you're using them, the files are sitting directly on RAM. If you're using a slower RAM, your CPU can't be as active and impactful because it's kind of waiting on that RAM to talk to it. The other thing I want to point out is while a GPU can complete more calculations, that's due to the fact it has thousands of cores. It actually is going slower. A fast GPU runs at about 1.9 gigahertz. Not many people know this, but I wanted to throw this out there. CPU performance can directly impact your GPU. The faster your CPU goes, the better performance you have on your GPU, because your CPU actually feeds your GPU and keeps it busy. This is one of the reasons you see gamers, quote unquote gamers, overclocking their CPU. It's not because they like to overclock, it's because they're trying to get better performance out of their GPU. This is what makes a Striker 2 workstation the best thing for visualization and real-time rendering. Just to throw that out there, I always like to show people this chart because it's very informative. First up, I wanted to add this slide. It wasn't intended, but we've been getting a lot of people coming back to us showing quotes from competitors with a SATA solid-state drive as the C drive. I really wanted to show this. The 980 Pro is the NVMe drive we use across the board in our system. On the Intel systems, Intel has not moved to the PCIe 4.0 bus yet, but the 980 Pro in the Intel processor actually goes 700 megabytes faster than the 970 Pro. When you look at the SATA solid-state drive, the max speed it can go is 600 megabytes. So the 980 Pro is actually faster than the 970 Pro by the speed at which that Samsung drive could possibly go, just to throw that out there. Once again, the beautiful thing about an NVMe drive is not just that it's fast. Thinking back to that image of the city is that it has high bandwidth to the CPU, right? It has a lot of bandwidth, direct access to that CPU. So it actually has a lot of parallelity to the CPU, which increases the CPU activity. And that's one thing we want to talk about. When we look at drives, we go with the fastest drives possible, right? The big opportunity on drives is to reduce your downtime. A lot of downtime that happens on computers is waiting for files to open or reading and writing the files if you're doing reality capture. Getting the fastest drive possible, and I mean literally the fastest drive possible, makes a huge impact to your system. A lot of our competitors and a lot of people go, well, can you get a generic NVMe drive? It looks like you can get one for about $40 or $50 less. We'll get to that at the end of the presentation, but these are the two drives we use. We use the 980 Pro drives up to 2 terabytes, and then we use the Sabre drives for the higher capacities. They're the fastest thing out there, especially for reality capture workflows. And drives are getting faster. They've already released the PCIe 5.0, and people are already talking about drives for it. So I know the drives aren't the most exciting thing in the world, but I'm kind of a drive nut. So I think you're going to see some really, really exciting things coming down the pipeline with drives. One thing about NVMe drives, they're 400% faster than traditional SSDs, and you get 80% increased processor activity using NVMe drives over a SATA drive. Okay, going back to RAM. RAM is extremely important. because it gives your computer a snappy feel. Okay, when you're working in Revit and you make a change or a command and you see that little green bar, the progress bar, or I like to call it the lack of progress bar if you have a slow computer. The faster the RAM, the lower the latency, the quicker that bar is completed. Literally, your processor is working with the file on RAM, which is why we use the fastest RAM we can possibly get with the lowest latency. We use a DDR3600 CL16, which is 40% faster than the majority of RAM you'll see out on the market. It's ridiculously fast, and it makes, I mean, honestly, anyone who's ever used our systems will tell you it's just snappy. It's very responsive. This is near and dear to me. So as we go in to start talking about graphics, I wanted to bring this up. I don't know if we have any visualization people in the audience. So 2010 Lumion came out. 2012 we had Synchro. 2013 was Enscape. 2014 was kind of the epiphany for me. Oculus Rift was released and the HTC Vive came out. I want to say it was about a $6,800 Dell system. It had 2 Xeon processors, 256 gigabytes of ECC RAM, and I had 3 Quadro graphics cards. I thought this was like the nicest computer in the world. Until I hooked it up to my HTC Vive and I got this error where it said system does not meet the minimum requirements. This is kind of where I started scratching my head, right? So I started looking at what graphics cards I needed to do virtual reality really well. And it was kind of counterproductive because Autodesk at the time was recommending nothing but Quadro cards. And everybody was saying for virtual reality, you needed GeForce cards. So I built myself my first system for me, and it had dual GeForce cards back then. And when we started BIMBOX, all we were doing and putting was GeForce cards in our systems. It used to be funny because back in 2015, Autodesk would not take your support ticket unless you had a Quadro graphics card in it. So when we were selling, 10 systems to a company, I would have to include a cheap Quadro card for the instance that they had to have an Autodesk support ticket. They could pop it in the BIMBOX, complete the service ticket, and then put the GeForce card back in. Flash forward to 2019. I don't know if everybody knows this, but NVIDIA released the studio drivers, and Autodesk now offers support for GeForce GPUs. I like to look back at this as a lot of people started digging into their system specs when they got this system does not meet minimum requirements. So it was kind of this epiphany, and this kind of drove Autodesk to release some of these support for those graphic cards. I want to throw this out here. If you have not downloaded the studio drivers from GeForce, if you have a GeForce graphics card, I recommend that you go out and do that. And this is one of the big things that change and that the studio drivers unlock for you. Before studio drivers came out, you were locked into 24-bit color on GeForce graphics cards. 24-bit color has 16.7 million shades of color, which seems like a lot, but for anyone that's done, photorealistic rendering or works in the visualization world, it's not enough for perfect scenery. If you look at the picture on the left, that's 24-bit. On the right, it's the same image rendered with 30-bit. 30-bit opens up the world for 1 billion colors. Okay, so right now, you can download these studio drivers. It'll automatically unlock your GeForce card to have 30-bit color. If you're using Enscape, Twinmotion, or Lumion, you'll get a much better rendering when you're looking at glass or anything that's fading colors through, reflections. It makes for a much better scene. Now that studio driver is unlocked and Autodesk supports GeForce cards, there's not really a place for Quadros in the AEC industry, especially with the release of the 30 series. And I kind of want to walk through that on this next slide. Not many people know this, but Quadros and GeForce cards are physical replicas. So to prove that, I want to show this, and not many people may have seen this, but right here we have a 2080 Super on the left, and we have a Quadro RTX 5000. Okay, that's its Quadro replica. If you look at the rendering configurations, they're the same. And if you look at the theoretical performance, they're identical as well. The only difference between these cards physically is the RTX 5000 has 16 gigabytes of RAM, and the 2080 Super only has 8. For the majority of workflows in the AEC industry, if you're not doing 4K rendering images, 4K images and materials in Lumion or really big scenes in Lumion and Inkscape, 8 gigabytes is more than enough. If you're doing CAD, Revit, Civil 3D, and a lot of that, the RTX 2080 Super is 8 gigabytes is more than enough for you. But look at the clock speeds on them comparatively. The RTX 2080 has a higher base clock, the same boost clock, quote unquote the same, and a higher memory clock. So for all intent and purpose, the 2080 is a better card. It has less RAM, but on paper, it's a better card. When we look at graphics cards, we actually go a little further. When NVIDIA releases a card, they release what's called a reference card. That's the card that NVIDIA sells. Then they also release that processor to aftermarket manufacturers. We work with EVGA. On the bottom right, that's an NVIDIA reference card. That's a 3070. On the top right is an EVGA 3070 that we use. It's an FTW3.
So
the difference, yeah.
Sorry, I got to interrupt. I mean, one of the huge noticeable difference that tends to stand out on the GeForce cards is the fans, you know, especially, you know, aftermarket compared to reference cards. And really, if you were to go back a slide and compare it to like a Quadro, if you go look at any images of Quadros, they typically will only have one fan and lack of aftermarket at the same time. Like, what would you say are kind of the importance of that?
So I would say that that's why I was saying quote unquote the same boost clock. Boost clock only happens when the card's running slower or when the card's running cool. So when you think about that single fan on the Quadro, that card's more than likely probably going to run that base clock frequency. As opposed to when we look at the top right EVGA card with 3 fans and all the extra heating components that we have, the cooling components that we have, it has a higher boost clock, and you see that higher boost clock more often, and it runs at a lower temperature due to all the adding heat fans, excuse me, and the additional fans that are added on there. So the better cooling, the better performance, and that's across the board. When you think about it, Brandon, a computer is just metal with current sent through it, and as long as you can keep that cool, you can continue to go fast. As things heat up, they automatically throttle down and you don't get the same performance. So the big thing to take away from here is all 3070s aren't the same, and all of them don't perform the same. That's kind of the takeaway here. So we go for high-end aftermarket cards as opposed to settling for reference cards. Okay, speed and temperature, and this is important to me. We get calls all the time from people about this. This is an Intel 10900K spec sheet on the right. You see 4.8, you see 5.3, 4.9 gigahertz, and then 5.2 gigahertz. The actual base frequency on the processor shown is 3.6 gigahertz. So I get people all the time calling me and asking, what's the speed of this processor? And truth be told, all these asterisks in the bottom left are things that have to be, conditions that have to be met before any of those happen, right? The big one is 70 degrees Celsius. So, you know, I think you were surprised last night when you actually checked the temperature on your computer and it was running 83 degrees. You know, cooling is a major thing. Intel has no idea what case you're going to put it in, what motherboard you're going to put it in, what power supply you're going to put it in, the cooling ability of the cooler you're going to use. So it really kind of comes down to the manufacturer and all the peripherals that they use and the settings they use for a processor on actual performance. This is theoretical performance until it actually gets put into a case. So before we go into how we cool systems, and some of the things that we do. I wanted to show this because this is theoretical. Every system will have a little bit different performance, and that's what we're going to get into here in a second. So at BIMBOX, we do something. We have direct die cooling, and we do that by delidding a processor. So the way that works is we start with a stock Intel processor. This is the Intel 9900K. The aluminum piece you see right there is a heat spreader. It is soldered by metal to the die. So the way it works is the die heats up, that heat goes through the solder, spreads out across that heat spreader, and then goes up to the cooler of choice of the manufacturer. We put it in here, we heat up that heat spreader with a heat gun, and then we close that, vice it, and separate the heat spreader from the die. This is what it looks like after that. We have to remove the excess glue and clean that PCB.
Yeah, first time I ever saw this, I was surprised at just the imperfections in that, especially in such a focused area of importance of dissipating the heat through from the Intel. Like, this is out of the box. Now, obviously, I've never had the chance to delid something myself. I don't have the money nor the time, or never even tried it to break CPUs. I don't have that kind of money to invest into it. So this is always interesting to see.
Well, I should have put a caveat that this is a successful delid. I'll tell you, we're really good and our techs are really good, but occasionally they don't use the heat gun long enough. And when you pull this up, the die is actually still attached to that heat spreader. It is not a fun day, but you toss it in the trash and keep going. So no process is perfect, but this is the next step to that process. We then have to use a chemical treatment to remove the excess solder and prep it for polishing, right? So the way that works is we put the taper on the PCB, we put on a corrosive chemical that eats away at that solder. You do it 3 or 4 times, and then you polish it down with the Dremel. This process is extensive. You're probably 45 minutes to an hour to get all that solder off. And then we have a polished die. This is what a die looks like. I don't know if you haven't seen what a CPU die looks like. This is what it looks like after we clean everything off and we remove the solder. After this step, we'll apply a really thin liquid metal, which is going to be our thermal compound. We'll modify our motherboard mount, and then we'll put it in there. So this is a die with our liquid metal ready for our cooler to be mounted to it. And that's going to be the direct die process. Want to show you 2 different types of cooling. If you haven't seen this, air cooling on the left, pretty much you mount an air cooler. It has heat pipes. The heat's transmitted up through those pipes. You blow cold air through it, hot air comes out. Only issue if your case doesn't have really good airflow, the hot air gets trapped in your case and it becomes an oven. Liquid cooling, you have a radiator. The one shown here is a 120 millimeter radiator with a single fan. We use a 360 millimeter radiator with 3 fans. You pump cold water across the water block, turns to hot water. You pump the hot water through the radiator. Cold air is blown through, hot air goes out. One of the reasons we really like this, not just that the blowing cold water over something is highly effective, but you can control where that heat goes. So you have a lot of control on how you dissipate that heat, which is one of the reasons we really like this method. Okay, cooling in action. So this is a really cool chart, and I think this is important. The top 2, the air-cooled and the 2 40 millimeter liquid-cooled, this came from Tom's Hardware. The bottom BIMBOX data came from us testing our Striker using the same stress test that they were using. This is with an Intel 9900K. This is the one we use, the processor we use in our Striker 2, using different cooling methods in a stress test. Okay, so air-cooled at 5.3 gigahertz, 5.2 and 5.1 gigahertz, the system wouldn't post. At 5 gigahertz, the system was running 100 degrees Celsius on the verge of failing. The 2 lines I want to show you, the blue line is where you would not experience boost, and the red line is 80 degrees. You don't want to run your system over 80 degrees Celsius. If you do it for long periods of time, your die will end up baking and it'll degrade your processor. At stock speeds, when they ran the stress test on these air cooler, it was actually running over 80 degrees Celsius, which just isn't safe. And once again, this was a stress test, so this isn't single core performance, but this is stressing your system if you were doing reality capture or a highly parallel workflow. This is simulating that. You have to stress test the system for that because someone might do that during their workflow. The 240 millimeter liquid cooler at 5.3, at 5.2, and 5.1, once again, the system wouldn't post. At 5 gigahertz, it's running 100 degrees Celsius again. And at stock speeds, we're getting a little better. You're down to about 85, 84, but it's still over 80 degrees Celsius. The big thing is at BIMBOX, with the direct die, with the de-lidding, and with a 360 millimeter cooler, and some of the things we do with our case cooling, we're able to run all of those speeds under 80 degrees Celsius with a stress test. The big reason we do that is we clock our computers at those speeds. So we don't ship them at unsafe temperatures. Our clients buy Striker 2s and they do reality capture. We just have to expect someone's going to do that every now and then. But all of these clock speeds are safe temperature, and we can run them like that. So that comes from our direct die process. If we did not do the direct die de-lid, we would not be able to run these temperatures. And I'll just throw that out there. So I just wanted to show this. This is a client ROI. Clark sent this information to us. Clark actually created a modified Revit benchmark. They use their own project files, a high-rise project. They use some mechanical modeling and some structural files as well. If you notice the configurations, they used a Intel 9900K, a 2080 Ti, and a 64 gigabytes capacity on the RAM. They are, identical. Brandon pulled that on me last night, and I laughed, but I'm going to leave that because they are identical. In the average single run, we were 39.3% faster, and in a 10-run duration, stressing the system even more, that number went up to 40 degrees Celsius. The reason that happened was over time, as things heat up and a cooler can't mitigate the heat, you get thermal throttling. Thermal throttling is what happens if you ever notice at the end of the day your computer feels like it's dragging. That's because your computer's heating up and its processes are slowing down. It's not just the computer's dragging ass and you're tired. It actually is the computer's dragging ass because the cooler can't keep up to it. And Brandon, yeah. I think you get this question quite a bit.
Oh yeah. Typically, right, when we're assessing this area and really coupling in everything that we put into the BIMBOX itself that separates it and makes it different. So while yes, these specs are identical, when you really dig into the specs though, they're far from it. And that's where, I get a lot of customers that'll come back and say, well, here's a configuration from Dell for $1,000 cheaper, or I can build my own for less or something like that. And that's where, when I look at their builds, it's like, well, but this isn't the same though. This is slower RAM. This is not NVMe storage or a slower, different type of or generic storage, right? Dell and HPs, they put a lot of generic components in, and down to the video card itself, right? There's 6, 7 different manufacturers for GPUs, all that have multiple variances of each and every model. So, I mean, when you look at some of the top of line ones like EVGA, which what we use, the FTW3s, the big key is there's the tri-fan, and overclocking from the manufacturer leads to that snappiness, that smooth rotation in Revit and in the programs that we use, all the way through to the RAM at 3600 megahertz and CL16 versus, in Box's case, in that particular model, I believe they were using 3200 at a CL20 or 21. Massive difference, but when you look at it on paper like this, yeah, they're identical. That's where we're seeing these performances and why. That's just now you start adding in the cooling focus, which take it away.
And this is that, going back to the aggregation of marginal gains, this is where we start seeing that chasm, right? This is the 1% adding up. And this is what we want to show you. I want you to start thinking about systems as well as case engineers. The way we're looking at this, there's an 80 millimeter fan on top, and then you have a 240 millimeter radiator pulling cool air in. Well, the next step is it's pulling the hot air from the radiator into the case, pushing it out the back, right? So the way our chassis is built, we have 240 millimeter fans on the back. We have positive pressure in our case. We built it and tested it like this. So you're always pulling more cool air than going out. The back fans actually aid in the bottom 3 radiator fans pulling out the bottom. So cool air comes in, little air comes through the GPU and then out the bottom. That's the idea there. We want to focus that energy outside of our case. We don't want that air, that hot air coming into our chassis. If you use BIM 360 design, this is definitely something you want to think about. Okay, Faith Technologies, they're a $1 billion electrical contractor in the Midwest. They came to us, they took on a new project, and they were having the time it took them to open files in BIM 360 design went from 15 minutes to 45 minutes. It was a huge project that they were working on. And that was huge. They had 40 people on their team. They saw that as $107,000 a month wasted time. I think it was 45 minutes. So 45 minutes across 40 people, and they were syncing 2 to 3 times a day. It was huge, right? So they bought 5 systems. They put them side by side. They started opening the file, and they timed it. We were able to get them down to 4.5 minutes. And it came from, I didn't even know this at the time. Apparently the syncing portion, the part that checks the file on your computer and then compares it to the cloud model, all happens in Revit, and it's all single core. So our Striker 2 5.2 gigahertz all core clock speed shredded that, making it the best system for BIM 360 design. They saw that as $107,000 ROI, recouped the investment in 3 months. CFO said it was the easiest decision he'd ever make. So if you use BIM 360 design and you're having a long time syncing, give us a call. We can help you out with that, or look for a faster system. Crossroads engineer.
We wanted to allow enough time for the ROI discussion and some questions too. So
Perfect.
I want to kind of wrap it up here.
Let's jump to this. This is the most important part of the project. I'm going to jump to this real quick. Let me pull this up real quick. So this is the biggest part that I don't want to take away. I want to talk about ROI calculator and productivity, because that was the goal here today. We have a great ROI calculator, and we have a Revit benchmark if you want to test it out. But this calculator can work for anything. I'll show it to you. The way we have this set up is you run our benchmark. We have one that's modified for RFO. If you need one for Revit 2021, reach out to us. We have our specs in there. We have our score in here. You put in your system. This is the Alienware that someone ran against our system. They put in their price in here, put their score in here, and it dropped down an increase in efficiency. Then we have the inputs, right? So we're going to set it to 1 person, billable rate of 100. And then we put in a 20% utilization rate. We're going to be really, really conservative in here because you can be, and it's still a big number, right? So 20% utilization rate. The reason we're saying that is a lot of things happen over the course of a day, right? Meetings. If you're sitting at your computer, you're probably not always working in the programs or applications that our computer increases your production on. So let's keep it at 20. And we saw 23% increase in productivity. We're going to cut that in half. Let's call it 12, right? 2,000 hours in a year. Hardware utilization rate 20%. So we have 400 hours we're actually working. We're going to increase that by 12%, which adds 48 hours of production, $100 per hour. We have 48 hours we're going to increase per year of production hours, right? We're adding that number of hours in potential hours we can work. So upfront cost difference, $27.99. Year 1 ROI, you're taking that 48 less the $27.99. 2-year ROI is $4,800. 3-year ROI is $4,800. Total 3-year ROI, $11,601. Okay. So, and this is being super conservative, right? So for an office of 10, That number is 116,000, right? So let's be a little bit more realistic. Let's say there's a 30% utilization rate, okay? There's $188,000 ROI. What I want to show you though, and this happens a lot, people get our systems and they, once they realize, hey, I bought in, right? So I got a 10% increase in efficiency. Well, you can make this efficiency rate like 5, right? So 5% increase in production efficiency, working 30% of the time, it's still a big positive ROI. Okay, so once people get bought in, trust me, Clark Construction called me every 6 months after someone gets our systems, they call me. And I swear to you, they always go, so is there anything we can do to make them faster, right? and the thing I like to show here is, you know, once you get these, so we have a 12%, which is half the 23, and we have a 30% utilization rate. People are like, well, if you double the cost, let's just say this is a $15,000 system. Well, it's still a positive ROI, right? So, I mean, what if it was a $20,000 system? It's still a positive ROI. What we're kind of trying to show here is a lot of times people come to us and they're like, well, you know, BIMBOX is expensive. And the thing is, we don't hear that from a lot of our clients. I always like to ask people, have you used one of our systems? The majority of our clients come to us after 6 months and say, hey, is there any way you can get us 5% more performance? Because what would 5% more get them? 5% more gets them a bigger ROI. 5% more adds to the production hours of their people, right? The big thing I want to show you here is there's a point where it doesn't matter what the system cost is. The objective here is to get your increase in production efficiency. Your time is valuable. And waiting for files to open, wasting time, waiting for things to happen in Revit, waiting for laser scans to be processed. While it doesn't feel like a lot, your valuable time is your best resource, right? I'm not telling you to go out and spend $30,000 on the system. I'm not, and there's a reason we don't charge $30,000 a system. We try to be responsible with things, right? We don't just make our products cost ridiculous amounts of money. It doesn't make sense to do that, and we don't show crazy ROIs. But what we try to show people is, if we can only get you a 5% increase in productivity, saw 23, you only work 20% of the time, it's a positive ROI. Your time is valuable. And that's the takeaway here. That's really what I hope you take out of this is there's an upfront cost of buying systems, and then there's your time. And your time is more valuable than anything out there. And if you don't take anything away from this, I tell you, when people ask us about our systems and they say, you know, what makes BIMBOX different, it's the aggregation of marginal gains. It's the fact that we always put productivity in front. And I tell you, there's a lot of cool technology coming down the pipeline, especially in the AEC. But the one thing I'll tell you about AEC hardware, most of our programs don't use a lot of hardware. Single GPU, single SSD, single CPU cores. So picking the right hardware matters. And if you don't have a good answer to the question I phrased at the beginning, reach out to us. And that's all I ask now. We could go on forever, David, but I guess I'll open it up for questions if anybody has one.
Yeah, thanks, Buck. Actually, while people kind of think of their questions, love for people to kind of jump in, but I wanted to thank you. This presentation is very technical. I know that, and like I geek out on it. I love it, right? But I wanted to kind of do a quick translation.
Yes, please. Thank you. I'm sorry.
One of the things that I just hope that it doesn't get lost, right? When you're talking about all cores across the board running at 5.2 or 5.3, what that really translates to is that snappiness that you're talking about. I wish there was a way to show it, right? And there's an intangible value I would say an intangible cost, and I have felt it over my career. Believe me, I'm, Mr. Revit in Seattle. I've over the years despised working in Revit many times. It's a combination of hardware catching up. It's a combination of software getting better. I understand. The reality is I don't hate it anymore. And I have my day-to-day, every day on this computer, I have open Revit, I have Revisto, I've got Synchro, and probably Bluebeam and a couple of other things. But those three things are constant. And the models I'm dealing with, I'm actively working day-to-day on over 1 million square feet of construction. And it's snappy. It's not, there's no click and wait. Yeah, you sync a model, you open, there are factors that you open a file, it's a large file, it takes a little bit. But when you're switching from Revit to Revisto, when you're switching to Outlook because you're answering an email, there's just no lag. And to put it, for lack of putting it a better way, I'm just not in a bad mood all the time because I'm fighting with Revit. I don't feel like I'm fighting with my computer. That to me is worth a lot more than anything on that ROI sheet. But I think that the ROI sheet kind of speaks for itself. So
just wanted to show, I appreciate the end user experience, because that's the three goals we set out for: create the end user experience. But I appreciate you reflecting on that.
And also I just wanted to thank you kind of for the lack of a better or a different word, that transparency. Yeah, I mean, you've talked about BIMBOX a lot, but I think you've given us really a glimpse into kind of like what the secret sauce is and what the factors are that contribute to that. I think that's huge. So I really appreciate that. And anyway, I'm gonna shut up and let you get to questions.
Yeah, we had a couple. Well, we had a laptop question here, and when we do have 17 and 15-inch laptops, obviously due to cooling technology in mobile chassis, we can only do so much. BIMBOX laptops have an additional fan in them, and really the components that are configured are not stock that you can find through other laptop manufacturers. It's just harder to find that, but we help you go through the entire process of understanding your software workflows, the programs you're using every day, and really just get you into the right machine. It doesn't do us any good just to over-spec and just provide you some ridiculously powerful computer when you truly don't need that. We want to set you up with success and make sure that we're speccing to your specific needs. Well, and Buck, if you want to share specifically around this, I know we didn't have time to get through the last like 3 or 4 slides, but show Purina and the situation of, so once COVID hit and everything hit the fan, they were faced with some of the same challenges that we all were, and that is, how do we maintain production, if anything, get faster, while still being able to accommodate a remote workforce? And so they tested several hardware solutions out there and pit us against them. If you notice in the lower right, another competitor, perhaps we analyzed there. But Buck, if you want to dive into a little bit of that and really just what they were able to accomplish.
Purina called us and they were like, well, we're looking for a remote solution. And I was like, well, we have desktop replacement laptops that run the same components as our Striker 2. And they were like, well, that's not what we want. And I was like, well, remote. And they were like, well, what about putting 22 workstations in a server room and running remote? And I was like, that sounds great. Like, if you have, so they moved their entire group, their production group, remote, and then bought all these. Their production team has never seen a BIMBOX. So this is the image of their server room, which is the chilled room, and they have KVM switches hooked up to this, and people remote into these. And work off of whatever hardware they have existing, cheap laptops, and have a wonderful experience. So I think there's a good option to do that. And then we have several clients that run BIMBOXes remote. They put it on their desk, hook it up to the network, and have a remote software that they can work from when they get to their desktop. They work on the BIMBOX, and when they're not there, they remote in. So you can have the best of both worlds. We do have a Striker 2, Striker Mobile, that has a desktop processor and runs fast. We also have a mobile, but our laptops, we don't have a super slim that's a 1/4 inch thick. We have our slim is about 1 inch thick, due to cooling, we focus on cooling. So we do have a mobile series. I didn't get into that today.
Yep, lots of remote solutions out there, and honestly, if anybody's interested in discussing that, I'm personally kind of digging into some other type of remote technologies for almost like a package solution. So in these situations where, you know, because there's other ways to handle that. Perhaps you get just a good enough laptop in order to display two 32-inch screens, as David is doing, and remoting in, right? So the screens are being portrayed or handled by the local laptop, and that's the most important thing. But remoting in, all the power is actually being done on the desktop itself back in the office. Now, on the IT side of things, that makes things easier to control and manage. I know that many companies don't necessarily like a lot of equipment in people's homes just because of the lack of control, but there are ways around that, and you know, we're open for that discussion anytime.
Yeah, and just last thing, if you got a computer and you bought it a month ago and it's running slow and you want to know, hey, how do I make it go faster? Give us a call. Maybe it's getting a new drive. Maybe it's tweaking it. I don't know what it is. Give us a buzz. We're happy to help, you know, recommend things and let you know. It's not, if you're not getting a BIMBOX today, we're not helping you. Happy to help you in any way you can.
Yep. And ATG overall, when it comes to the support side of BIMBOX, you're calling the same people that you would call for your software support. So Revit, Civil 3D, Navisworks, the Autodesk AEC line, Enscape, Fusor, V-Ray, many different programs that we use day to day that you're going to be calling, why isn't Civil 3D, or why isn't Revit doing this? Why isn't Enscape doing that, right? And the same team that supports that software also supports the hardware. So that's something that where, you know, we, let's just say 99% of the time, anyone calls in thinking it's a hardware issue. It's typically a Windows update, or maybe it's a Revit, you know what, actually Revit 2020.12 updated that, right? And that's something that you just won't get with the Dell or HP or Lenovo, because they don't understand our programs. They cover 90% of the PCs in the world. We'll stick with the niche that the AEC industry is, and, you know, the 10% and under.
Yeah, that's a great point. So guys, I wanted to really thank you and thank ATG and BIMBOX for joining the SeaRUG family. We really happy to have your expertise on board, and I think that's really a big differentiator, right? Is what you just said. It's I mean, I think that's very clear from this presentation that you know, you're people that understand AEC, understand our workflows, understand the solutions that we mostly work out within, and it's really great expertise to have. And I really want to thank you for joining SeaRUG. Looking at the time, kind of want to give people their afternoon back, get back to being productive. We'll post this up on the YouTube channel, and you know, obviously, if they want to get a hold of you, you know, what's the best way to get a hold of you post meeting if people need to reach out to you?
I'm Buck at BIMBOXUSA.com.
I'm B. Melin at ATGUSA.com. ATGUSA.com or BIMBOXUSA.com. You can, there's contact us forums. Absolutely reach out. We'd love to talk to you.
Yeah, and we'll put it on the we'll put it on the YouTube channel when we put up the video. I'll include some links to the respective websites and all that. So again, guys, really thank you. This is, to me at least, very enjoyable. I love hardware. This is really great information.